Can three numbers decide who lives?
Stop. I kicked off my day with hands-on machine learning practice on the classic Titanic survival dataset, aiming to predict survival probability using just three features: age, fare, and sex. I implemented logistic regression from scratch, using inbuilt Python libraries only for data handling and numerical operations while writing the model logic myself. I defined a logistic regression class, cleaned the data, implemented the sigmoid function to convert linear outputs into probabilities, and used binary cross-entropy loss to measure how wrong the model was during training. The core of the project was the fit function. I initialized the weights and bias, built a gradient descent loop, computed the linear model, applied the sigmoid, calculated gradients, updated parameters, and recorded the loss to visualize how the error fell over time. Predictions were kept simple and interpretable. Probabilities above 0.5 were classified as survived, and anything below as not survived. After splitting the dataset into training and testing sets, I pushed further by analyzing each feature independently. Initially, my code for extracting age-only, fare-only, and sex-only probabilities was incorrect, so I used Gemini for guidance on structuring separate inputs and running independent logistic fits. This allowed me to generate three clear probability curves. The results showed strong patterns. Younger passengers had higher survival chances, survival probability increased with ticket fare, and women had nearly 5 times the survival probability compared to men. When all three features were combined, the final model achieved 76.34% accuracy. For a model using only 3 parameters, this outcome highlights how even simple, well-built models can uncover meaningful signals in real-world data. After finishing my machine learning work, I switched into quant prep and focused on number theory fundamentals. I started with Euclid's algorithm to find the greatest common divisor using repeated division, then extended it using Bezout's identity to express the GCD as a linear combination of the original integers. What stood out was how the same division steps that shrink the numbers also reveal the final relationship between them. I then moved to proof-based problems, beginning with the idea that an irrational number always exists between any two rationals. This led naturally to showing that there are infinitely many rationals and infinitely many irrationals in any such interval. Rationals by repeatedly inserting averages, and irrationals by generating distinct irrational values within the same range. I also revisited why irrational numbers are uncountable, understanding that while rationals can be listed, the real numbers cannot, and removing a countable set from an uncountable one still leaves something uncountable. To end the session, I practiced the greedy algorithm for base representation. Given a real number and a base like 6, I converted the integer part by repeated division and the fractional part by repeated multiplication, step by step building its full base expansion and reinforcing how number systems work beneath the surface. Then came the trading block of my day. I analyzed XAU/USD and my higher time frame bias pointed short. I follow my rules to the letter: clear stop loss, well-defined take profit, and proper lot sizing. Entered the trade calmly and avoided the temptation to micromanage it. Once the position was live, I let it run in the background and shifted my attention to my DSA lecture instead of wasting time staring at price ticks. That lecture introduced dynamic programming, a problem-solving approach where a complex problem is broken into smaller, overlapping subproblems, each solved once and stored to avoid redundant computation. It's a powerful shift from brute force to efficiency. Knapsack is the classic example used to explain this idea. Given limited capacity, How do you choose items with different values and weights to maximize total value? We covered 3 variations. The 0/1 knapsack, where each item can either be taken once or not at all, is solved using dynamic programming. The fractional knapsack allows items to be broken into parts and is solved using a greedy strategy by always picking the best value-to-weight ratio. The unbounded knapsack allows items to be used multiple times and again relies on dynamic programming. While I was deep into DP and knapsack concepts, the trade continued running quietly in the background. It came painfully close, about $300 away from my take profit, before the market reversed, pushed straight into my stop loss, and took me out. Almost immediately after, price flipped again and ran to my original target. A classic stop-out scenario. I closed the day with a $953 loss, which was frustrating but fully within my plan. No impulsive decisions, no revenge trades, just discipline, execution, and a reminder that in trading, consistency and process matter far more than any single outcome. I practiced the 0/1 knapsack problem on Geeks for Geeks, focusing on understanding the dynamic programming transitions instead of memorizing code. I briefly used GPT to clarify why the transition works, then implemented the solution myself. The core idea is defining a DP state as the maximum value achievable using the first I items with capacity W. For each item, you either exclude it and keep the previous best value or include it, if possible, and add its value to the best result from the remaining capacity. Filling the DP table row by row ensures all subproblems are solved in order, and seeing the logic turn into working code was genuinely satisfying. On the coding side, I solved 3 binary tree traversal problems on LeetCode: pre-order, in-order, and post-order. Pre-order processes the node first, then left and right subtrees. In-order visits left, node, then right, and produces sorted output for a binary search tree. Post-order visits left, right, then node, and is useful for bottom-up computations. All 3 follow the same recursive structure: return on null, recurse left and right, and place the visit step correctly. A key bug I fixed was accidentally recursing on the global root or passing node values instead of nodes. The fix was simple but essential. Always recurse on the current node's children and reference the current node when appending. I'm finishing this daily series soon. From day 28 onward, I'm tightening the format. 1 clear concept per video. Thanks for watching.
The network awakens. Intelligence takes form. Undegreed. The signature remains.